Let's continue talking about the Encor exam. In this case, another quality of service component. In this case, we're going to talk about buffering. I am going to split this session in 4 parts. We are going to go from the easy part of buffering into increasingly complex topics. It is not quite difficult, but the Cisco documentation that is out there is quite large, and it is even contradicting at some points. So I will try to summarize it the best I can, and I will try to explain it in the most easily manner that I can find. So let's go to the first part. In this case, let's explain or talk what is buffering. Buffering is a component of quality of service where we are going to store data packets inside buffers within a network device in order to absorb transient bursts of data. If you charted network utilization in detail, going into the milliseconds realm or even further, you will see that network utilization is not constant. That is not what happens in reality. In reality, we have bursts, peaks of traffic and then nothing, and then another peak of traffic and then nothing, and then another peak of traffic. That is what happens in reality. So we need to have a space of memory where we are going to store packets that are waiting to go out into the line, and that we are going to call buffers. So in Cisco Catalyst 9000 we have this technology that is known as dynamic threshold and scale that will help us to allocate and deallocate both buffers to ports, and this will happen dynamically. When reading this Catalyst 9000 documentation, you may come across this term, which is the system buffer. This system buffer is what is known as PBC or packet buffer complex. The PBC is something that is inside the UADP chipset, and the buffers live there. We are going to be able to pull some buffers out of there in order to allocate them to ports. So ports can allocate those buffers to queues where actual data packets will be stored before sending them on the line. Every single of these single buffers that exist in the PBC are up to 256 bytes in length. So this is the first part, and we're going to see the easiest way to influence buffering. So let's say that I have maybe 1000 soft buffers available for me in an interface, and I want to have a way to be able to assign these buffers differently to my queues. So in order to do so, I'm going to use the command QBuffer ratio, and I'm going to establish a percentage. So let's see, for instance, this example, I have these 2 queues. This first queue, if you notice, is a priority level queue, number 1. So it will be my priority queue number 1. That is my first queue. And then I have another queue, which is the class default queue. And I am using this command QBuffer ratio in order to influence the amounts of buffers that are going to get assigned into my queues. you might think, if reading this 50% and 50%, you might think that you are going to see something like, if we had, let's say, 1000 buffers, and then you will get assigned 50% to the first queue, that is a priority queue, and then 50% to the other queue. You will be wrong. This is not the way it works. There is actually an internal set of math formulas that will apply to this number, and then after calculating these formulas, then the operating system will actually be able to calculate how many buffers it will assign to the priority queue number 1, and how many buffers it will assign to the priority queue, to the queue that belongs to the class default. It is not as easy as this. This is not the way it works. We are going to see some examples later on. Remember that this session goes from easy to complex. So if you want to stay at this point, you may use the command QBufferRatio and provide a larger ratio to your queues that will need to move more packets, or will have more to accommodate or to face more bursts. This is a first way to influence buffer with QBufferRatio. So this is a larger example. In this case, we have this policy map, and we have this queue, 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 and we have this queue. Remember that if you have a policy map, you will have at least one queue, which is the class default queue. And remember that for Catalyst 9000, you have up to 8 queues at the egress. You may have one from 1 to 8, because if you're using a policy map, you will have at least one queue, which will be the class default queue. And then you can play with your other queues. For instance, this is the priority level queue number 1. Remember that in Cisco Catalyst 9000, you may have 2 priority queues, the number 1 and the number 2. In this case, we are only using the priority queue number 1, and this other class has another queue. This another class will have another queue. As long as you don't have more than 8 queues, you are set. And we are saying that this priority queue will get assigned a QBuffers ratio of 20. Class 2 does not have a QBuffers ratio. Class 3 has the QBuffer ratio of 10. Class 4 gets a QBuffer ratio of 10, and the class default gets a QBuffer ratio of 40%. So we might assume that this is assigned at 20% in order to reach the 100%. Remember that these percents will not reflect exactly this percentage that we are assigning here, and the math formula, a formula gets applied in order to figure out how many buffers gets assigned into each queue. So you can stop watching this session now if you want to only know the basics of buffering. Now we are going to move into the second part. That is where the things start to get a little bit more complex. There are 2 types of buffers: hard buffers and soft buffers. The hard buffers are also known as dedicated, and the soft buffers are also known as shared. So the hard buffers are reserved by port. So these buffers will only get assigned to a single port, and the port will not be able to let them go. The system will not take them, and when I say the system, I am talking about the dynamic threshold scale process will not take these hard buffers into account in order to allocate it into another port. However, soft buffers can be shared among different ports. So you may have one port that is not currently using the soft buffers. So these soft buffers will be able to be taken by DTS and get them assigned to another port. So if you want to figure out with this information that you already have, you might want to know, okay, so how many hard buffers do I have in a port, and how many soft buffers do I have in a port per queue? So remember that when you want to look after the hard buffer amount, remember this is how the operating system calls the hard buffer amount. We will call it HARDMAX. Remember, this value is deterministic because this amount of these buffers are not movable. The port will always have this amount of buffers. DTS will never take those buffers away from a port, because these buffers are always allocated to a port. So these buffers will guarantee that there are existing buffers for the priority queue number 1. And then your port queues will have sub-buffers. And in order to look after them into a show command, remember to look after the SOFTMAX value. So the SOFTMAX value will tell you what is the maximum amount of soft buffers that your queues within a certain port will get assigned. So the maximum buffer allocation per queue for burst absorption. Remember that this value is opportunistic. It doesn't mean that this particular queue in this port has this amount of buffers. It can grow up to that, but this amount of buffers is only usable if the system actually has the amount of buffer units available. So dynamic threshold and scaling will provide you with SOFTMAX buffers if there are buffers available. If all the buffers are used, this value is not guaranteed. Compare that with HARDMAX, which is giving you a value that is always existing within your port. It is permanent. Your port will always have access to these HARDMAX buffers, amount of buffers. So if you want to influence how many soft buffers will get assigned to your ports, you can use the SOFTMAX multiplier. So we are going to use this command, QoS Q SOFTMAX multiplier, and then apply a number. This number by default exists and it is equal to 100. So if you want to influence DTS into providing you with more buffers to your ports, you can, for instance, increase this to 150 or 200. Remember that this change will not have an effect on the priority queue number 1, because priority queue number 1 only uses hard buffers. This is a command that will influence the allocations of soft buffers. So it will influence the value of SOFTMAX, but it will not influence the value of HARDMAX. So as I told you before, there is a buffering math. If you really want to know what is the way that the operating system uses in order to figure out how many actual buffers each queue will get, you will need to get familiar with these formulas. So there are several constants and values. There is something that is known as the base buffer. This is a value that is intrinsic to each hardware platform. Then you have the user multiplier that we already mentioned, which is known as the SOFTMAX multiplier. It defaults to 100, but you can increase it. There is the hidden multiplier that defaults to 4. And there is the Q ratio, which is a command that we already saw that applies to each Q. Now, the values that we want to find with these formulas are SOFTMAX and HARDMAX, because we want to know how many hard buffers my port will have, and we want to know how many soft buffers my queues that are not priority queue number 1 will have. So in order to calculate HARDMAX, we are going to multiply the base buffer by the Q ratio. In this case, this will be the Q ratio that you configured for your priority queue number 1. And then for priority queue number 1, SOFTMAX just will be equal to HARDMAX. Then for any other queue, in order to know the queue SOFTMAX, you will have to multiply the base buffer by the hidden multiplier that defaults to 4 by the user multiplier that defaults to 100 and divide that by 100, and then multiply that for the Q ratio that you configured for your queue divided by 100. So this is not really complex. It is an easy formula, but if you have to remember this formula plus all the formulas you already know for Cisco, it starts to become a memory issue. So let's see this example. For instance, we have this queue for class 1. Notice that it is using the priority level 1 command, so this is my priority queue number 1. And it is applied a Q buffers ratio of 20. So remember that in order to calculate the HARDMAX value for the priority queue number 1, we are going to multiply the base buffer by the Q ratio divided by 100. So using that internal formula, in this case, the operating system is finding out that the HARDMAX value is 240. We can, with this value, we can actually figure out what is the base buffer, because this is, using this formula here, we can say that base buffer equals to HARDMAX by 100 divided by the Q ratio. So we might want to, for instance, calculate that. So I have been doing some maths previously, and for instance, if the HARDMAX is 240 and we're going to multiply that by 100, and then we're going to divide that by the Q ratio. The Q ratio is 20. So we now know that the base buffer is 1200. So we're going to use this value in order to figure out why the operating system came up with these other values. So we are still analyzing priority queue. The other formula that we have is that for priority queue number 1, SOFTMAX equals HARDMAX. So SOFTMAX is going to equal HARDMAX. So that is why we have 240 here and 240 here. So let's analyze the next queue. So for the next queue, we have this. We don't have a queue buffers ratio. We are going to step. Let's analyze the next one. For instance, this one has a queue buffer ratio of 10. So the formula is SOFTMAX will be the base buffer, which is 1200. We're going to multiply that for the internal multiply with multiply, which is 4. We're going to multiply that by the user multiply, which we know with is 100 by 100, so that will give us 1, and we're going to multiply that by the Q ratio by 100. In this case, the Q ratio is 10. So let's bring up our calculator here. So it is I'm sorry, 1200 by 4 multiplied by 1 by 10, and let's divide that by 100. And that is why this Q gives us 480. This has a ratio of 2 and 10. This other Q here that belongs to class 4 has a ratio of 10, so the same formula here applies, and it will give us the same result. And then for the class default Q, we are going to use the same formula. We're going to multiply 1200 by 4 by 1, and then we're going to multiply that by the Q ratio, which is 40, and we are going to divide that by 100. So let's calculate that. Let's calculate that. We're going to multiply that by 4, and then we're going to multiply by 1, which is the user multiplier. Remember that you can change this user multiplier. And then we're going to multiply this by 40, and then we're going to divide by 100, and the result is 1920. So this is the actual value that we have here, 1920. So given this is 40% and 10% and 10% 60 plus 20% here, we can conclude that this Q here that doesn't have a percentage will actually get 20% in order to reach 100%. If we add 40 plus 10 plus 10 plus 20 plus 20, we have 100%. So now we have this value figured out. Let's apply the formula. Remember that the formula will be 1200 by 4 by 1 by 20 and divide that by 100. So let's bring up the calculator. I don't find it. Okay, so let's calculate that. 1200 4 by 1 20 divide that by 100, 960. So that is why we have this value here. So this is the way to calculate HARDMAX and SOFTMAX for the priority queue number 1, and what are the formulas to calculate SOFTMAX for each of the other queues. So let's go into more complex features. Part number 3, remember that DTS, that stands for dynamic threshold scale, will allocate and deallocate buffers to your ports and queues. So there is actually a way that DTS will use in order to allocate and deallocate buffers from you. It will not just provide them or remove them from your port queues in a single shot. It will allocate and deallocate using an step value. So we need an step value for the deallocation and allocation process, so DTS can provide your ports and queues with buffers and deallocate these buffers from your port and queues. So in order to do so, DTS will need two values: SOFTEND and SOFTStart. SOFTEND will be calculated using SOFTMAX by 2, and SOFTStart will be calculated using SOFTEND multiplied by 0.75. So the SOFTStart is the 75% of SOFTEND. So using these values, we can calculate a step. So for instance, if SOFTMAX were, for instance, 1920, PortSoftEnd should be that value multiplied by 2. So in that example, if we had 1920 multiplied by 2, SOFTEnd will be 3840. And PortSoftStart will be the 75% of that. So we are going to multiply these by the 75%. That will be 2880. So these will be 2880. And SOFTMIN is a value provided by default. You can also influence this value. It is also calculated using a formula that we haven't seen yet, but let's say that we have this value. So with these points, we can calculate here a line. So DTS is going to use this step. DTS will use that in order to know how many buffers it will allocate or deallocate from your port queues at each time. It will not do so in one single moment, but it will continuously deallocating buffers from your queues. I hope that make any sense. So let's see, for instance, this example. We have these queues here, and this is your SOFTMAX. In this case, if we want to calculate the PortSoftEnd, we are going to multiply that by 2. So we get this number. And then if we want to calculate the PortSoftStart, we are going to multiply this by the 75%. And then we are going to get this value. Okay, so let's go to the final part of this session. We're going to talk about stacked buffers and egress port buffers. There are actually several types of buffers in your Catalyst 9000. You have 2 stack buffers, from stack buffers, and egress port buffers. Your your stack buffers are actually buffers that are using by something that is known as an stack interface. This stack interface, you can think of it as an interface that connects your UADP's chipsets. So you have an UADP here, and you have another UADP here. So there is an interface that connects them. You just think it logically. In that term, it might not map that into the physical equipment, but just think it in a logical diagram manner. So if there are buffers that are assigned to this stack interface, for the packets that are entering your switch, there is a process that is known as ingress queue scheduling, or IQoS, that is going to be in charge of some buffers from the stack interface. From packets that are ready to start leaving your switch, they will have to go through the stack queuing scheduling process, or SQS. SQS also is going to use buffers from the stack interface buffer set, and then your ports will use the egress port buffers. These are managed by the Active Queue Management System, or AQM. So we could say that all the buffer terminology that we have been discussing so far with DTS only has access to this, the egress port buffers. DTS does not have access to the from stack buffer managed by the SQS, or the to stack buffer managed by the IQS. So stack buffers are not available by default to egress ports. So in order to make them available to egress port, these buffers that exist here in the stack, managed by IQS and SQS, you can use this command, QoS stack buffer, if your switch is happens to be Catalyst 9300, particularly these two types, and only if you have an iOS XE at least of being 16.12.1, or for if your switches have an UADP 3.0 and you have a iOS XE that is equals or larger than 17.2.1, you can use this command. So QoS stack buffer for 9300s, and for UADP 3 base catalyst, QoS share buffer. So you can make use of buffers here from your stack for your egress ports. That's it.